Good evening, everyone. It is once again Ted the Speed Learner, and this is an update to Pappus Book 7, Proposition number 238. And the reason I'm uploading this presentation tonight is because I incorrectly drew the proof in my last presentation that I uploaded many months ago. So here's what I'm going to do. I am going to paste the hyperlink to this presentation into the description box of my last presentation. That way, if anyone watches that presentation, they will come over here and watch this one and get the updated version. Now, Pappus was a Greek mathematician that lived hundreds of years ago, and he wrote all of his works in Greek. Now, not too long ago, there was a gentleman who translated the works of Pappus, okay? And he then wrote a book about it. Now, I was able to obtain a copy of Pappus Book 7, Proposition number 238. I do not have access to all of Pappus's proofs, just to that particular one. Now, I wrote this gentleman and I asked him to send me an illustration of the proof because all I had was the words. I didn't have an illustration. And he was gracious enough to send me an illustration to this particular proof. Okay? So, what I'm going to do is I'm going to place his name in the description below, and I'm also going to place a hyperlink to his books in the description below so that you can go ahead and you can purchase his book and you can take a look at it, etc., etc., etc. Now then, let's go ahead and illustrate Pappus Book 7, Proposition number 238 correctly. Okay, let me read you the proof. The proof goes as follows. These things being so, we go back to the original problem. Let line AB be given in position. So let's go ahead and draw line AB just like this. There we go. A, B. Okay. Now then, the next thing I'm going to do is I'm going to draw the Greek letter for our letter C. Okay? In the English alphabet, we have the letter C. In the Greek alphabet, they have a different letter. But it's the same letter. It's just in the Greek. Okay? So, and C given in the same plane. Okay? This Greek letter here is the same as our letter C. Now let me make sure you can see this. Oh, that's much better. Okay, now you can see this. Okay. And let delta C be drawn across. Now, do you remember in a previous video when I showed you the Greek letter delta? Well, we're going to put it right down here. To us, that would be the letter D. We're going to draw this across. Now, it's not straight across, it's just across, just like this. Okay? And now we're going to draw delta sigma. Do you remember in a previous video when I showed you the Greek letter sigma? Well, there is the Greek letter sigma. Okay. Now then, let me read this again. These things being so, we go back to the original problem. Let line AB be given in position. There's that. Let C given in the same plane. Remember, this is not in two different planes. This is going to be in the same plane. Not an airplane, but like a rectangle. Okay, let's say we made a humongous rectangle. It would be in the same rectangle. It would be clear out 3D. Okay? I know you saw a lot of that in Euclid Book 11, but we're not in Euclid Book 11. We're in this Pappus proof, okay? So, and C given in the same plane, that's this one, and let delta C, which is this, be drawn across, and delta E be drawn as a perpendicular. Delta E is perpendicular to AB. And let the ratio of delta C, we're going to have a ratio of this to this. Okay? The ratio of delta C to delta sigma be given. Okay? I say that this delta right here, this is Pappus speaking, of course, touches a section of a cone, and if the ratio is equal to equal, it's a parabola. Okay, so if this ratio between this and this is equal, it's a parabola. If this is less than this, it's an ellipse. And if this is greater than this, it's a hyperbola. We're going to focus on the parabola. We're not going to worry about the hyperbola. We're not going to worry about the ellipse. The reason for that is because of parametric functions, the Bezier curve, and the rest of calculus. Most of calculus is based on cones and parabolas. You'll see that in later lessons. Okay? For first, let the ratio be equal to equal. We're going to say that this line is 2 inches long, and we're going to say this line is 2 inches long like that. That is first, let delta C equal delta sigma. We're going to say that these two lines are equal. That way we can prove that this is touching a parabola. Let perpendicular CZ. We're going to draw a perpendicular just like this. And that's going to be Z. Let perpendicular CZ be drawn. Hence it is given a position. And let delta H parallel to AB. I'm going to draw this one right here. Do you see a triangle there? Well, of course you do. That's going to be very important. And since the square of delta sigma equals the square of delta C, let's say we square both of these numbers. Okay? So now it's not just 2 squared anymore. Okay, we're going to say that these two numbers have been squared, and we're going to square both of them. This is going to be 4. And this is also going to be 4. Just like that. Now let's read this again. Let perpendicular CZ be drawn. We've done that. This is H here. And and delta H is parallel to AB, which it of course is. And since the square of delta E, that's this line, equals the square of delta C, which is this line, and delta E, which is this line, is equal in length to ZH, which is this line right here, and the square of delta C equals the squares. Now here we go. What we're going to do is we're going to say that the lengths of these are X and Y. Okay? That's what we're going to say. We're going to say that the length of delta H is X and the length of HC is Y. Okay? So what we're going to say is that X squared plus Y squared equals delta C. That's what we're going to say. Let me make sure you can see this. Turn this around just a bit. There we go. Perfect. Now then, why did we say this? Does this remind you of anything? Well, it should. It should remind you of the Pythagorean theorem. I'm going to say that again. It should remind you of the Pythagorean theorem. That's what this is. That's why we have this 90-degree angle right there. Get it? Good. Okay. Now then, it says And the square of this equals the squares of this and this. Therefore, what we're going to do is we're going to replace this term right here with ZH. Now, do you know why we were able to do that? Because we said this length is equal to this length. And because this length is equal to this length, and this length is equal to this length, therefore, by the transitive property, if A equals B and B equals C, then A is going to equal C. Well, this length is equal to this length. And that's how we can get away with that. Okay? So, therefore the square of ZH, this is this one, equals these two squares right here. So I'll read it the way it says. Therefore the square of ZH equals the squares of delta H, which is this one, plus the square of HC, which is this one. And CZ is given in position. This is given in position. And Z and C are two given points. This one and this one. Thus, this touches a parabola. Now then, you say, well, what is this? What is this point? Why is it so important? Well, I'll tell you why. Because it's the focus. Delta here is the focus of a parabola. Whether it's going up or it's going down, doesn't make any difference. This is the focus of a parabola. Now then, what's AB? Well, I'll tell you exactly what AB is. That is the directrix. Delta is your focus, AB is your directrix. And that's where it all comes from. That's why this proof is so important. Now, this proof, if you read on a little bit further, will reference Pappus Book 4, proposition number 34. And I was able to find on the internet a reference to Pappus Book 4, proposition number 34. And part of it goes like this. Let me go ahead and erase all this. Just like that. Part of it goes like this. You have a circle. Well, you actually have a half a circle. And the proof starts out, what they do is they divide the circle into 3 equal parts. And what you do is you start with this 1/3 here, and when you go through the rest of the proof, you begin to realize how related Pappus, and I'll write down Pappus Book 4, P for proposition 34. I'm not going to write out all of proposition there, but you get it. Okay? And you will see how interrelated this is to Pappus Book 7, proposition 238. Now, do you see why it was so important to tell you all this? This has to do with parametric functions, Bezier curves, and, well, a great chunk of calculus. It's all based on this. And now you know it. Now you know it correctly. Okay? Well, I want to thank you very much for watching this particular presentation. I think you can realize how important all this is. If you can't, just leave me a comment below. Alright, I will tell you more in a future video, so I would like for you to stay tuned.